All right, everybody, welcome back. Today, we're going deep on something I think is pretty cool. Linear algebra.
Ooh, yeah.
I know for some people when they hear that, they're like,
It's scary.
oh my gosh, flashbacks
To school.
to some tough classes.
Yeah.
But stick with us, because this stuff is really,
A foundation.
it's incredible. It's the foundation.
That's
It's like,
right.
we always talk about AI and machine learning as these
Yeah.
big, complex systems.
Systems.
And it's like linear algebra is like the bedrock.
The building block.
It's the building blocks, yeah.
Yeah.
So we have a great piece here that really digs into this. And I think it's going to be a fun one. So
I'm excited.
let's hand it over to you to kind of break down, like, what is linear algebra and how is it?
Yeah, so how does it actually play a role in this?
And all this AI stuff.
Yeah, so the really cool thing about linear algebra is that it essentially gives AI and ML a way to talk about the data we throw at it.
Okay.
It's like the language of AI in a way.
Yeah.
And the core of that is like vectors and matrices.
Okay, yeah, I've heard those terms before, but
Yeah.
I need a refresher.
Yeah.
What are those?
So think of a vector like this. So you've got weather data, right?
Right.
Temperature, pressure, humidity. A single vector can pack all that in. So, maybe at this point in time, it was this temperature, this pressure, and this humidity that gives you a location in 3D space.
Okay.
And then a matrix is kind of like, think of like a spreadsheet
Okay.
where each row is a different data point and each column is like a feature of that data point.
Got it.
Like you could have a matrix of like all your friends and how much they like different movies.
Okay.
So like their ratings.
Okay, so we're kind of like translating from our world into like
Yeah.
math,
You're
essentially.
into a mathematical representation, exactly.
Which the computer, the AI can understand. Okay.
Exactly.
So then is it like word embeddings
Yes.
that we hear about in natural language processing? Are those?
That's a perfect example. Okay.
Yeah, those are vectors. So each word gets its own vector.
Okay.
And what's really cool is that the vectors capture the meaning of the word in relation to other words.
Okay.
Like king minus man plus woman equals queen.
Proud.
Like you can do that with vectors, which is crazy.
That's super cool. So we've got these building blocks. Now, what about something like neural networks?
Neural networks.
Which are kind of like the brains
Yeah.
behind AI.
Yeah, so believe it or not, matrix operations power the learning process in neural networks.
Okay.
So like you've got all this information flowing through the layers.
Mm-hmm.
It's matrix multiplication that's making it all happen.
Okay.
And even the weights and biases that are constantly getting adjusted as it learns are stored as matrices and vectors.
So when we hear about these like massive neural networks and all the data processing they're doing,
Yeah,
it really is like at the core.
at the core, it's just, it's matrix multiplication.
Wow. So what does matrix multiplication actually look like?
Yeah.
Can you give us how do we...
Hand rule example.
Yeah. So think of like you have a recipe.
Okay.
Okay. And each ingredient is like a vector.
Okay.
It's got like the amount of each ingredient.
Okay.
And then when you combine them all together, according to the recipe, you're doing something very similar to matrix multiplication.
Okay.
You're combining things in a specific way to get an output.
Okay.
And in a neural network, it's like the ingredients are the data points, and the recipe is like the network architecture,
Yeah.
along with all those learned weights and biases.
I got it. So we can handle these huge data sets.
Huge.
Like how do we even make sense of all that?
That's where dimensionality reduction comes in.
Okay.
And like one of the key techniques there is called principal component analysis, or PCA. So like imagine you have a room that's just full of furniture, like way too much.
It's chaos.
It's just chaos.
Yeah.
So that's like high dimensional data.
Okay.
PCA helps us find like the most important pieces of furniture, the ones that really like define the room and get rid of the clutter.
Okay.
And those are the principal components.
Okay.
So it's all about simplification without losing the core information.
So it's like finding the signal within the noise.
Exactly, yeah.
Okay.
And PCA is used all over the place, like image processing, text analysis, even compressing data.
Wow. So it's really popping up everywhere.
It's everywhere.
It's more than just like the basics.
It's not just like the numbers. It's,
Right.
Yeah,
It's being used for all sorts of cool things.
it is.
So we've talked about neural networks. We've talked about dimensionality reduction.
Yeah.
What are some other areas
Yeah.
of AI where this pops up?
So like recommender systems, think about like Netflix.
Okay.
They use matrix factorization, which is like linear algebra,
Wow.
to figure out what movies you might like
Okay.
based on,
Everyone's ratings.
everyone's ratings.
Okay.
Then there's support vector machines.
Yeah.
Or SVMs, they use linear transformations to classify data, whether it's like images, text, even sentiment analysis.
Cool. Any others?
Yeah, like optimization algorithms like gradient descent, they rely heavily on linear algebra to like fine-tune those neural networks
Okay.
by adjusting the weights and biases,
Right.
even in like analyzing social networks.
Wow.
And patterns, linear algebra plays a role that eigenvalues, which is another concept, can be used to make sense of those complex connections.
It's really amazing to me to think about
Yeah.
how this kind of underpins
It's fundamental. Yeah.
so many different areas
Yeah.
of AI and ML.
It really is.
And it makes me wonder, given how important it is,
Yeah.
do you think people should be learning like basic linear algebra just to
I think it's a good question.
Yeah.
Like, how much could that help people just
understand the world around them?
understand the world around them? Yeah, because AI is everywhere.
Yeah, that's a great point. Well, this has been a really fascinating deep dive. I've learned a lot.
It's fun stuff.
It is fun stuff. And for our listeners, I encourage you to check out this piece that we'll link in the show notes. And keep learning about linear algebra because it's really cool.
It's everywhere.
It's everywhere.
All right.
Thanks, everybody. We'll catch you next time.
See you.